All right, moving on to section 9.4. This section we're going to talk about sequences, both arithmetic and geometric, and we're going to be able to express those sequences explicitly and recursively. We are also going to get back into limits now. We're going to be talking a lot about limits coming down the stretch here this school year, especially as you head into AP Calc next year. So they want us to find the first 6 terms in the 100th term of the sequence a sub k, excuse me, where a sub k equals k squared minus 1. So a sub 1 would be the first term, so k is 1, so 1 squared minus 1 would be 0. A sub 2, and now all you're doing is you're just plugging in the numbers. So 4 minus 1 is 3. A sub 3, 3 squared minus 1 is 8. A sub 4, 4 squared minus 1 is 15. A sub 5, and so on. Okay, we're just plugging in the numbers. First 6 terms, so A1 through A6. Okay, and then for the 100th term, okay, k is 100, so that's 100 squared minus 1. Well, 100 squared is 10,000. Okay, so that's 9,999. So that's easy enough. Okay, take the number of the term, plug it in for the variable, figure it out. Now, when we do, now that was explicitly what we did right there. Now let's talk about recursively. So again, same thing, except this time, okay, this time, we're doing the first 6 terms in the 100th term, but now it's a recursive sequence. So it says find the first 6 terms. So B1 is 3, they gave us that. B2, okay, now this right here, when they say B sub n minus 1, what they're talking about, that's the previous term, okay? So really what you're doing is you're just taking the previous term and adding 2. So B sub 3 would be 5 plus 2. B sub 4 would be 7 plus 2. B sub 5 would be 9 minus 2. Okay, that's a 2. And so on. Now, the 100th term. Now, this is interesting. Okay. Now, here's the thing. You can kind of tell by these numbers that it's increasing by 2 every time. Okay? The sequence starts at 3. Okay? Now, here's the thing, guys. If I knew the 99th term, I wouldn't have to go through any of this. I'd just take the 99th term and add 2. Well, we're not going to go all the way up to 99. So, kind of a shortcut would be to take the first term and add, well, there are 99 instances where it goes up by 2. So up 2, up 2, up 2, 99 times. So I'm going to add 99 times 2. So that's 3 plus 198. So my 100th term would be 201. Okay? So that is a unique situation. Okay? So recursively, you can't just plug in the number of the term and figure it out like we did explicit. Okay? You got to do some other things. All right? And really, like I said, the only thing that really affects is like something like the 100th term. Okay? The first 6 terms, you're just adding 2 to the previous term. Okay, limit. This is really important. Okay? So you have a sequence. All right? If we take the limit, okay, as n approaches infinity of a sub n, if the limit is a finite number L, so if the limit is a number, that means that the sequence converges. And then L would be the limit of the sequence. If the limit is infinite or not existent, then the sequence diverges. It's a very important thing right there, okay? Now we're going to do a bunch of examples. It says to determine whether the sequence converges or diverges. If it converges, give the limit. So for part A, okay, it's the limit as n approaches infinity. So that means n gets real, real big. Now, what is happening here? Okay, it's 1 over n, right? So, I mean, we're just the first term, the bottom number is 1. Second term, bottom number 2, 3, 4, 5. So that's our limit. So here's the thing. As n gets large, 1 over that approaches what value? Well, it approaches 0. Okay? So the limit of 1 over n as n approaches infinity is 0. So it converges because it approaches a value to a limit of 0. Okay? Now take a look at B. Alright? The limit as n approaches infinity. Now, what's happening in B? Okay? What's happening in B? Basically what's happening is the top number is 1 more than the bottom number. So we can write that as n plus 1. If I could learn how to write a plus sign, that would be critical. Over n. Okay? Now, it's difficult to look at it like this and kind of figure out the limit. Let me see if I can rewrite this to kind of help us out here. What if I took each term on top and divided by the bottom? N divided by n is 1 plus 1 over n. So all I did is I took each term on top and divided by the number on the bottom, or by n on the bottom. Well, we already know that 1 over n approaches 0. So the limit is 1. Okay? Because this approaches 0, 1 over n. So this converges because the limit turned out to be a number. C. Okay? Now, the limit as n approaches infinity. Whoops. Now, what's happening in C? You're basically taking each term and doubling it. So that would be 2n. Okay? Well, what happens? Alright? Well, as n gets big, well, 2n gets big. It gets really big. So really, the limit is infinity. It approaches infinity. Well, here's the thing. If the limit is infinity, that means it diverges. Because remember, infinity is not an actual value. Okay? So that diverges. Last one. Okay? Now here's the thing. We don't even have to worry about a limit here. Because really there's no rule. What happens? These terms just alternate from -1 to 1. So what we say is the sequence oscillates. That's a fancy term for goes back and forth. Okay? So this sequence oscillates between 1 and -1. So there's no limit. Okay? There is no limit. It's not infinity, it's not a number, it just goes back and forth. Alright? Now, what does that mean if there's no limit? That means it diverges. Okay? So that's finding limits. Now, this next example, I think is very instructive because I think that we can visit an old friend. Okay? We can visit an old friend. And that old friend would be horizontal asymptotes. Now, I don't know if you guys remember how to find a horizontal asymptote. Okay? But here's the thing. It says determine whether the sequence converges or diverges. If it converges, give the limit. So I have the limit as n approaches infinity of 3n over n plus 1. Now, if you remember back to when we did horizontal asymptotes, when we wanted the horizontal asymptote, we looked at the degree on top and we looked at the degree on the bottom. Now remember, degree is the highest exponent. So the highest exponent on top is 1, because there's just an n, and then on the bottom it's 1. Well, what happens if the degree is the same on the top and bottom? Well, all you do is you divide the coefficients. So 3 divided by 1 is 3. So this sequence converges. Okay? Now the second one, limit as n approaches infinity, this time of 5n squared over n to the third plus 1. Now in this case, the degree on top is smaller than the degree on the bottom. So, what does that mean? Well, that means that as n gets big, the limit's going to be 0. Well, since the limit's 0, that's a value, so it converges. For the third one, limit as n approaches infinity of n to the third plus 2 over n squared plus n. Now, this time the degree on top is bigger than the degree on the bottom, so when that happens, the limit is infinity. Well, whenever the limit's infinity, the sequence diverges. Okay? So that's the exact same process. Now, when we graph this, okay, if we were to graph it, we're not, but if we were, there would be no horizontal asymptote for this problem, right? Because the limit would be infinity, and you can't graph that. Okay, arithmetic sequence. All right? Now, this is the formula, okay? They do a lot of different things here. Here's the formula. A sub n equals the first term plus n minus 1 times d. Now, the number d is called the common difference, okay? So it's either the number that it goes up by every time or the number it goes down by every time, okay? Now, recursively, this is the formula. Okay, so this is explicit, and this is recursive. Okay, so for number 1, and we're only going to do number 1, we're not going to do number 2. Okay, part A says find the common difference. Okay, well, it appears that our common difference is positive 4 because we're adding 4 every time. Part B, the 10th term. Okay, so the 10th term, we're going to use the explicit formula. So a sub 10 equals a sub 1. Well, the first term is negative 6 plus, now remember, n is the number of term. So n is 10 minus 1 times the common difference, which is 4. So that's negative 6 plus 10 minus 1 is 9 times 4 is 36. So the 10th term is 30. Now, part C says I want a recursive rule for the nth term. Well, very simple. A sub n equals a sub n minus 1. I'm just using this formula now. Plus 4, because that's plus the common difference. Okay? Now, we have to put the disclaimer in here. Okay? For all n greater than or equal to 2. Now, why is that disclaimer there? Because when n equals 2, 2 minus 1 is 1, that's really the first term. So really it's the previous term. If n was 1, 1 minus 1 is 0, and that's no good. So it has to be for all n's bigger than or equal to 2. Now, the last part, an explicit rule. Well, here's our explicit rule. So I have a sub n equals the first term, which is negative 6, plus n minus 1 times 4. So that's negative 6 plus 4n minus 4. So if I kind of rearrange some terms here, that's 4n minus 10. Whoops, that's a 10. Well, that's a terrible 10. Okay? So there's our explicit. All right? So it's very simple. All right? You just got to follow along. And we did some of this in Algebra 2 last year. Geometric sequence. Okay, so now for a geometric sequence, here is the explicit formula for geometric sequence. Okay, you're going to have a sub n equals the first term times r to the n minus 1. Oops. Come on. Don't tell me I got to erase this. Ugh. Good grief. Alright, so it's a sub n equals the first term times r to the n minus 1. Now, the number r is called the common ratio. So in other words, it's the common number that everything gets multiplied by or divided by. That's why it's geometric. Here is your recursive formula. So we're going to do the same thing here. This time we'll do both. So 1a, it says find the common ratio. Well, every term here is being multiplied by 2, so r equals 2. 1b, what is the 10th term? Well, if you're going to find the 10th term, use the explicit formula, so a sub 10 equals the first term, which is 3, plus, whoops, not plus, times, times r to the n minus 1. Well, r is 2 to the 10 minus 1 power. So that's 3 times 2 to the 9th. So if you figure that out, 3 times 2 to the 9th is 1,536. Now, the recursive rule is very simple. So here's your recursive rule right here. So a sub n equals a sub n minus 1 times the common ratio, which is 2. Now I can rewrite that. Okay, put the 2 in front. So 2 times a sub n minus 1. Now guys, remember, a sub n minus 1 is the previous term. Okay, it's the previous term. Okay, 1d. Write an explicit rule for the nth term. Explicit. Well, now come up to your explicit formula. A sub n equals a sub 1 is 3 times the common ratio to the n minus 1 power. Okay? So that's all you have to do for that. In the interest of time, I'm going to skip the second example. We're just going to do that first one. That kind of shows you what to do. Okay, last one. We have to construct sequences. All right? The second and fifth terms of a sequence are 3 and 24 respectively. Find explicit and recursive formulas for the sequence if it is arithmetic or geometric. So here's part A. Okay, so we're going to do arithmetic first. All right, so we know what the second term is. Okay, well, a sub 2 would be the previous term plus whatever the common difference was. All right, well, the second term is 3. All right, now the fifth term would be the previous term plus 4d. Now, why 4d? Well, let's just say you're going up by 2. Well, if you go from the first term to the second term, you're adding 2. Well, if you get all the way up to the fifth term, you're really adding 8 because 2 times 4 is 8. But a sub 5 is 24. Okay? So, actually, no, I'm sorry. Let me go back. That should not be a sub 4. It should be a sub 1. To find the fifth term, you take the first term and add 4 times the common difference. Okay? That's my bad. Okay, well, what are we going to do here? We have to find the common difference. Well, how do we do that? Well, here's what we do. We take a sub 1 plus 4d, and we subtract a sub 1 plus d. Okay? And then we set that equal to 24 minus 3. Now a sub 1 minus a sub 1 goes away. 4d minus d is 3d. So 24 minus 3 is 21. So D is 7. So that's our common difference. Okay. Now, what does that mean for the first term? Well, 3, which was the second term, equals the first term plus 7, because that's the common difference. Minus 7 to both sides. The first term is negative 4. Okay, so our explicit would be a sub n equals, okay, a sub 1, negative 4, plus n minus 1 times 7. Okay, so a sub n equals, let's see, this is 7n minus 7. So 7n minus 11 would be the explicit formula. Now, your recursive would simply just be a sub n equals a sub n minus 1 plus 7. Okay. Now, that is if the sequence is arithmetic. Now, what happens if it's geometric? Okay, so if it's geometric, that means that a sub 2 equals a sub 1 times r to the first. Okay, 2 minus 1 is 1. Well, that's 3. Whoops. The second term is 3. So a sub 1 times r to the first. A sub 5 is a sub 1 times r to the fourth power. Okay. Well, a to the fifth, or the a to the fifth, a sub 5 is 24. Now, when you find the common difference, you subtract the second term minus the first term. That's for arithmetic. For geometric, the common ratio you divide. So you take the bigger term, a sub 1 times r to the fourth, and you divide a sub 1 times r. Now that's going to equal 24 divided by 3. The a sub 1's cancel out. R to the fourth divided by r is r to the third. 24 divided by 3 is 8. So you take the cube root of both sides. Your common ratio is 2. Okay, well, so what does that mean? The first term, a sub 1, whoops, your first term, so we come right back to here. Okay, so a sub 2, the second term was 3. That was given. Equals a sub 1 times the common ratio, which is 2 to the first power. So divide both sides by 2. The first term is 1.5. So your explicit formula for a geometric sequence, a sub n equals 1.5 times 2, common ratio, to the n minus 1. Your recursive, okay, your recursive is simply a sub n equals 2, the common ratio, times a sub n minus 1. Okay, long video. I apologize. Split it up into parts if you want, but that's how you do sequences and that's how you find them. Okay.